A very good day everyone. We are from group A7. We are here to determine the bending moment and bending stress that act along the bar, and let's continue with the procedure. A bar is fixed between these two planks, and different type of person with different load are asked to hang over the bar, and data are recorded based on the different type of person hanging on the bar and different amount of force exerted on the bar. And let's continue with our team.
Because of the applied loadings, beams develop on the internal shear force and bending moment that in general vary from point to point along the axis of the beam. In order to properly design a beam, it therefore becomes necessary to determine the maximum shear and moment in the beam. One way to do this is to express V and M as functions of their arbitrary position x along the beam's axis. This shear and moment functions can be plotted and represented by graphs called shear moment diagrams. The maximum value of V and M can then be obtained from these graphs. In order to formulate V and M in terms of x, we must choose the origin and the positive direction for x. As you can see now, when a lightweight person hangs on the bar, the bending effect is not that obvious. Now, when a moderately weight person hangs on the bar, the bending effect on the bar can be slightly obviously seen. Now, when a heavier person hangs on the bar, we can see that the bending effect of the bar is obvious. The shear diagram for the lightest person shows that it's getting steeper. It's not that steep when you compare with the person which has the shear diagram where it shows the graph is more steep. And when you look at the moment diagram, the peak of the curve is getting higher as the person's weight increase. So this actually shows the tendency for it to bend. The higher the peak, the more the bar bends. Thank you.